This is Mohammad Sadiqur Rahman. So today I'm just discussing about my understanding on assignment number 7, that is called Deep Q network. So in this assignment, we will learn how to train an agent with Deep Q networks using algorithm so that the card pool can be balanced. So this is the performance of an untrained agent that cannot balance the card pool. And the following one is our desired card pool that has been able to balance itself after the deep Q network training. So for that, at first we're just importing our necessary library functions from TensorFlow and Keras. And for training in some deep Q network algorithm, we're just importing the sequential and all the for some importing for putting some hidden layers. We're just importing dense function from Keras of different layers. And this is the environment that is given in the gym.make carpool version 1. So this is the environment that for the agent will take some observation from the environment, and according to the learning, it will perform some actions. And based on this action, the agent will be rewarded or getting punished, that is a positive reward or negative reward. And by this way, it will learn how to optimize the reward, to maximize the reward, and how to perform trans successfully. So for the card pull, there are only two actions, that it can go left and right. And the observation is in the number 4, that is the position of card pull, the velocity, the pull angle, and the pull velocity. And if the card pull doesn't fall, that is, then in that case it will collect a reward 1. So it will try to maximize the reward 1 so that until the pull doesn't fall down, and it will be the episode will be terminated if it is called done, or uh, it will take some steps, and it will be terminated when poll is successfully okay. Actually, so there are some flags so that the episode will just declare that episode has been done or not. So for that, we are taking random actions from our random sample functions, and we're just resetting the environment and taking this random action with some in environment or step function. We're just observing the random observations on reward, and we're just printing that. That is action 0. That is action 0 means the push card is moving on the left. And for that, it has 4 observation, that is a velocity, position, pole angle, and the fourth one was velocity. And we're just printing the options. So this reward is 1. That means the pole has not been fallen. Done equal false. That is, it has not been correctly able to pull the pole. And the number of action that we taken, that is 2. That is from left to right. And this is the limits of the observation: the maximum position, maximum velocity, maximum pole angle, and so on. So at first, there is to helper function, that is, I have to select an action based on the training. That's why we're just defining a class function, that is select action. That will take some argument here, that is current exploration rate, what is observation, and what is the DQ agent has been able to perform. So we're just taking them random value, and if it is less than the exploration rate, it will choose a random action from 0 to 1 with equal probability. Otherwise, it will just, according to the prediction of observation by the Q agent, it will maximize the action value. And it will just return the action that is 0 or 1. Whatever the pole will move right or left. Then the next helper function is the replay function. Here we are just want to find our quality value. So there are two types of network, that is called policy network and target network. For target network, this is the formula for calculating the quality value, that is the immediate reward, and gamma times, these are the next action and next state for that will give quality value, and we have to maximize this value. So ultimately q theta s comma a, that gives the quality value of the target network, whereas q beta s a gives the policy network, and this has the difference that is called temporal differences. So when to minimize these temporal differences, where is prime and a prime is the next action and next observations, and based on that, that is the quality value. So to minimize the TD error, the policy network parameter beta that can be optimized. So the first exercise is about to train the model based on the experiences collected so far. So in the for the replay class function, it takes some argument, that is memory, the agent, target agent, some batch sizes, and the gamma value. So it is just taking some batch state and for quality values for each state. And if I give the memory and batch size argument, it will randomly sample these batches, and it is just calculating the target network quality value by this formula that I have already discussed before. And but on the prediction of the current observation, you will just update the current quality value and action, and so on. And based on this, the DQN agent will work to fit this network. And now we are just in the time of learning the parameter, that is maximum storage 75, and gamma that is related to the target network quality value, that is set to 0.97, and memory and update steps, that is updated steps after 10 episodes, and the best side is set to 64, learning rate is set to 0.001, and for optimizer algorithm we use Adam from Keras TensorFlow. So now it's the time to train the network. So we're just defining sequential as equal agent. We're adding some hidden layer with 64 kernels, 64 kernels, filters actually for number of observation, and we're giving the activation file functions as a ReLU function. Then we again add some hidden function or dense function with 64 filters with activation ReLU function, and third layer is of 24 filters activation ReLU function, and the fourth layer is a number of action, that is 2, and activation is linear as it has only 2 outputs. Then finally we're just compiling, and on the loss function we're using some MSE, mean square error, and optimizer is called Adam with the learning rate that has been defined before. So this is the summary of the DQ agent. Total 6090 parameters need to be tuned. So now we'll start with 100% exploration and gradually decrease it to 5%. So initially it is 1, and then decay it is 0.95. Minimum will be 0.05. Yeah, this is 5%. Okay. That this is the main training loop. It will change the counter for how many times the code is running, and it will just calculate the reward. So you start with the exploration start value as 1, and it just print that, and it will read the score and time steps. So at first, well, and it's not done. That will take the current exploration as 1, current observation value, and the decode agent, and based on this value, from select action for class function, it will select a suitable action, and for this action, it will take some steps, and it will just observe, you get some information about that. What should the next observation, current reward, whether the work is done or not, and some other informations. So there is a experience that is saved to the memory about this current and current observation, next observation, and current action reward, and whether the action has been done or not. And the memory that based on this experience, it will be saved to the memory, and then it will print the current exploration rate with the time steps and what is the score already you collected for this action. So that will go until the length of memory is greater than or equal to the batch size that has been defined before. The DQN agent will be updated by these arguments, and it will continue to print the exploration rate, the and the time steps and the value. So in total, the training time is 839 seconds. If I plot this graph, then we find these types of graph that is with the progress in episodes, the rewards is getting higher and higher. That is the system, the agent is is able to balance the cut pull. And if we want to record this video, then we'll just import these pip functions, and we can just run it for this video, and this is for 2 seconds. It can be shown here, but we can also terminate the above SL, and we can also load an agent that has already trained for 1,000 episodes. And if we run that, it is shown there for 16 seconds. It is indeed able to solve this balance. So that was all about my understanding. Thank you.